Hi, I'm going to do the project on tall building design in this video. So the tall building that I'm taking is this. This is a 23-story tall building of different plan for different set of similar stories. These are the cross-sectional of the elements that I'm going to use that are columns and beams, and slab is of 150 mm thickness. The material that is going to be used in this structure are M40 concrete, HYSD 500 and mild steel 250, and this structure is to be covered by auto cladding of 0.2 kN per meter. The wind load that is going to be imposed on this structure as per Bangalore condition. Now I am taking a new model in ETABS for the design of this tall building, which is a part of the project assigned to me. So I will select this display unit as metric SI and the database as per Indian, and for steel IS code 800-2007, and as per for concrete IS 456-2000. Okay, so now the number of grid lines in X and Y direction are 4, or the spacing are 6. So I will just change the spacing to 6 meter, and the number of stories are 23, and the height is 3 meter. Now I have to customize this story as per the stories are different. There are different set of stories here. So up to story 8 all the stories are similar, so I will just make this story 8 as master story, and all the story below story 8 as similar to story 8. So I have to just make the selection as similar to story 8, all the story below it. Similarly, from story 9 to 14 all the stories have similar plans, so I have to just select all the stories as similar to 14. Okay, so I will just select story 14 as master story, and the stories similar to story 14. The story is also similar to story 14. This is also similar to story 14. This is also similar to story 14. Now similarly from 15 to 19 all the stories are similar, so 19 as master story, all the story below it are similar to 19, and one set of the stories, similar stories, are all same as 23, and which is already given, so I will just left it. Okay, so all the similar set of stories are defined. Okay, now I will choose a grid only option, and okay, so now we have the plan of the building and the 3D model of it. My system is little bit slow, that is why it's taking so much time. So here we will have the plan. So I am on right now I am on 23 story, and this is the 3D model of the building. Okay, first of all I have to define the material. So for this I have to add a new material. For as per the Indian condition I have to define the material type as concrete, and for I am going to use, for this I am going to use M40. Okay, I will set all these values as default, and again for the concrete, not for concrete but for rebar, concrete has already been defined, so HYSD grade 500, and again I will leave this as default, and again I will add new material as under the rebar, mild steel 250. Okay, so all the materials that are going to be used in the construction of this building have been set. Okay, now I am going to define the sectional properties for the elements that are going to be used. First I will define the properties for column, so I will add the properties for column. Okay, I will choose a rectangular concrete section, and I will choose a property for column as column. First one is 500 by 500, and the material type is that is used for the construction column is M40, and this is also 500 by 500. I have to define the rebar properties as well, so I will select the rebar properties for column and HYSD 500 and mild steel 250. All the properties to be left as default. All the values that is present there are to be set as default. Okay, now I am going to add a copy of this, because all the different sections of beams are of similar properties, only the dimensions are different. So I will just define a new section of 550 by 550 just I have to change the depth and width, and all the properties of rebar and everything are similar. Okay, because it had already been defined. So I will just make another copy of it, and this time for the column section 600 by 600. So I will have to just name it. Okay, M40 and 600 by 600. So this is done. All the column sections have been defined. Now I will add a auto select list for the column, so that the software will select the best suitable column section. Okay, so this is the column auto select for concrete. I will prepare this as auto select list. Okay, so auto select list for column is defined. Now I will define section properties for beams. Similarly, the beams are like B 500 by 300, and material is that is to be used for construction of beam as M40, and depth as 500 and width as 300. I have to modify the rebar property as for the beam, and longitudinal bars as HYSD, and confinement bar as mild steel 250. I have to change this clear cover value as per the IS code for top and bottom bars, and that is 25 mm. Okay, this is done. Now I have to make copies of this beam section, because all the different beam sections will have same properties, only the dimension will be different. So this is 550 by 350 M40, it is okay. 550 by 350. Okay, now one more section for beam that is to be left to be assigned, that is defined, that is beam 600 by 400. Okay, I have to make an auto select list for this beam also, so I will just prepare auto select list for this beam. For beam auto select. Okay, this auto select design type is of concrete. For this beam, this auto select list is for beam. Okay, now all these things are defined. Now I will define the slab section. Okay, under the section property slab, I have to add the new property for slab, and I have to just name it as 150. The material that is used for construction of slab is M40, and the thickness of slab here is 150 mm. Okay, so the slab section has been defined. Now I have to do the drawings. Okay, I have to draw the columns, beams and slabs. Now I will jump to the plan of story 1. And I have to choose this for similar stories. Okay, now I will draw columns using quick draw column option. I have to change this property to auto select column, and I will just draw this as per the given plan, since the plan of story 1 to 8 is given. So as per the plan, I have drawn the columns on the floors for the floors 1 to 8. Okay, similarly I have to draw the beam, and for this I have to choose a property as beam auto select. Sorry, on the property type side, beam auto select. Okay, so the beam is also constructed in a similar fashion. Now I have to draw the slabs. Okay, and slab is section is already defined. I will choose that 150. So slabs, beams, columns, and all these three things are drawn for the stories from 1 to 8. Now I will jump to story 9, which is from 9 to 14, which are having the similar plan. Okay, so story 9 and 14 are similar set of the story. So story 9, just I have to draw the columns first. Okay, properties are already defined, and this is done for similar properties, and as per the plan I am drawing this column. Okay, in this manner, and similarly beams on it. Okay, finally I will lay the slabs. The slab property is already defined as slab 150. Okay, so the beams, columns and slabs for from story 9 to 15 are drawn. That is okay. Now I will jump to next set of similar story, that is from 15 to 19. So I will jump to story 15, and I will draw the columns as per the given plan. So as the plan given to me, I am drawing this column. Similarly, using quick draw beam option, I am drawing the beams. Okay, so beams and columns are constructed. Finally I will lay the slabs, and one more set of similar stories are left, that is from 20 to 23. Okay, slabs are laid. Now I will jump to story 20 for the construction of columns, beams and slabs. Okay, now I will just draw the columns as per the given plan, and as per the plan the columns is to be drawn like this, and similarly the beams using quick draw beam option, and similarly the slabs. Okay, so the construction of slabs, columns and beams for different floors of this 23-story building has been constructed. Now I will impose the several loads that is acting on this building. So first I will define the dead loads. For this I will jump to story 1. Okay, now here all the stories are subjected to same kind of dead load, means dead load of same magnitude. So I will apply this dead load for all story. So I will select, first I have to escape from this draw tool. Oh, my system is a bit slow, that is why it is taking time to escape from this draw mode. Okay, so I have to first impose the dead load, then I will apply the live load, then I will apply the loads due to cladding. Okay, and then finally I will apply the wind load. So the 4 different kinds of load that I am going to assign here. Okay, for this first of all I have to make the selection of the slabs, and this is I am doing this for similar stories, not for similar story because I am going first for dead load. So I will do it for all stories because all stories have same magnitude of dead load. Okay, now I will assign all the slabs of 23 floors are of from floors 1 to 23 are selected, and I will impose the cell loads of uniform nature of 2 kilonewton per meter square, that is the dead load that is acting on each slab, 2 kilonewton per meter square of dead nature, and I will just apply it. Okay, so dead load is applied to every slab on each floor. Okay, now I will change this to similar story down here, and now I will apply the live load from story 1 to 8. Okay, now I will select again the slabs, and I will assign cell loads uniform of live nature but of magnitude 5 kilonewton per meter square, 5 kilonewton per meter square, and I will apply this. Okay, right, now I will apply the loads due to cladding on the exterior beams. Okay, for this I have to make the selection. For this I have to make this selection of exterior beams. So I will select the exterior beams, from story 1 to 8. And loads due to cladding is of 0.2 kilonewton per meter, and it is since it will rest on these exterior beams, that is why I am assigning these loads on this beam frame. Okay, now this is 0.2 kilonewton per meter, and I will just apply it. Okay, so 0.2 kilonewton per meter of load due to cladding is applied on each of the beams, exterior beams from floor 1 to 8. Okay, one beam is left for selection, so I will just apply it again. Okay, so all the different kinds of loads, that is live load, dead load, and load due to cladding, are applied from story 1 to 8. Now I will jump to story 9 for application of live load, okay, and load due to cladding. And the live load from story 9 to 14 is 4.5 kilonewton per meter square. For this I have to just make the selections. First I will just show this is for similar story. Okay, now I'm selecting each of these cells, and I will assign cell loads of uniform nature and that is of live load, and that is of 4.5 kilonewton per meter square, and I will just apply it. Okay, so 4.5 kilonewton per meter square of live load is applied. Now I will select these exterior beams. Okay, so I'm just selecting these exterior beams, and I will assign the loads, distributed loads on it of 0.2 kilonewton per meter. Okay, so the load application for 9 to 14 is completed. Now I will jump to story 15. Okay, so on story 15 I will apply the live load of 4 kilonewton per meter square. Okay, so I'm going to assign the, first of all I have to do the selections. Okay, display uniform shape, and I'm selecting each of these cells so that I can apply a load of 4 kilonewton per meter square on it. Live load of 4 kilonewton per meter square is on it, and apply on it. Okay, okay, and now load due to cladding is to be applied, and finally one more set of similar load, that is from 20 to 23 is left. Okay, so just have to apply the load due to frame of 0.2 kilonewton per meter. Okay, just last set of similar load, that is from 20 to 23. Okay, done. Okay, I will jump to story 20. This is the last set of similar story, and I will apply a live load of 3.5 kilonewton per meter square. So assigning cell loads of uniform nature of 3.5 kilonewton per meter square. 3.5 kilonewton per meter square, that is of live nature, and apply it. Okay, so and similarly, okay, I haven't selected the cells, sorry. I have to assign the cell loads uniform nature 3.5 kilonewton per meter square. Okay, now I have to make the selections of exterior beams for the application of load due to cladding, that is of again 0.2 kilonewton per meter. So to just carefully select this exterior beams, and now I will assign the frame loads of 0.2 kilonewton per meter. It has already been assigned here, so I will just apply it. Okay, now one more thing that is to be done, that is on story 23, above story 23 there are no claddings, so I have to remove the claddings, that is cladding load that is applied on story 23. For this I have to make the single story selection. For this I have to change this as one story down here, and now I have to select the exterior beams. And I have to delete this frame load from it. I have to delete this existing load. I have to apply it. Okay. So the part for imposing loads of dead load, live load, and load due to cladding are done on each of the story. Okay. So right down here, I can also go down and see this story. Okay, so here the load due to cladding is present, but here the load due to cladding is absent. Okay, so now I have the next step. On the next step, I have to first I will just go to the base. Okay, and I will go to the base. I'll go to base and restrain all these joints as fixed joint. For this I have to select one story down here as one story. Okay, single story. Now I have to select the joints. All the joints are selected. Now I have to restrain it as fixed joint. So all the joints are fixed. I have to apply it. Okay, now one more thing that is left to be drawn is the cladding. For this cladding I will use the auto cladding option. Okay, so all the joints are restrained, and just I will draw the auto cladding option, and I will use the flows. So the cladding part of the structure is completed. Sorry, I haven't made the selections. Okay, no, it's okay, it's lagging. This is, my system is a bit lagging. Okay, so the cladding part is done. We can see that, we can see that the structure has been cladded, and now I have to impose the wind load on it. And for this I have to just define this load pattern. Okay, and I have to make here as a wind load. and I have to change this type as wind load, and as per the IS 875/1987 I have to add this load to this load pattern and modify it. Now we are designing this building in Bangalore, so as per the Bangalore condition, the wind speed is 33 meter per second and the terrain category is of free, while this building is of class C, and the K1 and K3 factor are 1 as computed from the IS code, and all the things are okay. So I will just select this and okay, done. The load pattern is assigned. Now I have to just apply the wind pressure coefficient as per the IS code. So I will just take the elevations. Okay, let me move to floor 1. Okay, and I will just take the elevations. Okay, so for section A I will choose section A first, and as per the code, this side the wind pressure coefficient is 0.8, and I will just make this selection here as similar stories, not for similar stories, for all stories. Okay, and I will just select all the slabs, sorry, all the claddings, okay, on this section A, and I will just assign a wind pressure coefficient of 0.8 plus 0.8. okay, and this is on windward side, so I will just apply it. So wind load is applied on this side. Similarly, I will just do this for section B as well. For the section B, on the elevation side, I will just choose the section B. Okay, for the section B, I will take the section B and apply this similar wind pressure coefficient. First I have to select this, just make the selection, and I have to just assign this under the cell load wind pressure coefficient of 0.8 on the windward side. Is also on the windward, this section is also on the windward side. Okay, just applied, and now the section C and D are on leeward side, and as per the IS code, okay, it is applied. Okay, okay, now as per the IS code, it is minus 0.25. okay, it is minus 0.25. it is not selected, just deselected. Okay, no, load is applied. Okay, so I have to just move on to side D first, and then impose the wind pressure coefficient of minus 0.25 on it. Just make the selections like earlier, and I will just assign the cell loads wind pressure coefficient of this time. This is minus 0.25 and this is on leeward side, so I will just apply it and okay. Similarly, the section that is C, we are assuming that the wind is flowing from left to right, so the section C, for section C I am taking the elevation of section C, and this is for the elevation for section C, and I will just apply the wind pressure coefficient of minus 0.25 on leeward side. Now the section 1, 2, 3, 4, these 4 sections are on leeward side and imposed to similar wind coefficient of minus 0.28, sorry, minus 0.8. okay, this is okay. My system is a bit lagging, so it is taking selection twice. Okay, done. Now I will take the elevation for section 1, and I will do the selection from 1 to 4 simultaneously, and then apply the wind pressure coefficient, since it is similar for all this section. and I will just move to section 2, and I will do the selection of all the claddings in a similar manner. Similarly, on 3, similarly on 4. Okay. And the wind pressure coefficient is minus 0.8 as per the IS code. So this is minus 0.8, and this is also on leeward side. I will just apply it. So all the loads due to wind are applied on this structure. Okay, so different kinds of loads are imposed: dead load, live load, load due to cladding, and wind load, and also all the elements are constructed. So the building is complete to run analysis. So I will run the analysis, and before I will run the analysis. Okay, so before that I will try to extrude this view. Okay, now this building has been extruded, so I can see the different section, that is the beams, columns, has been extruded. Okay, so this is the view in 3D. Now I will run the analysis. For this I will choose the analyze section, and I will just run analysis. Okay, for this I have to save this first. So I will save this by names tall building project. Okay, so I have buildings. Okay, it's okay. So I have saved this. Now analysis is going on. That is, it is running the analysis. Okay, it will take some time to run the analysis, and after running the analysis I will check it for design parameters. I will check whether start the design check on it, and whether we will see whether all the members are passed or not. Since we have taken here the auto selection option here, so the software will try to take those sections which are economical. So if this structure fails in the analysis, then it will reiterate again, and it will take section of larger size, so that it can it becomes safer. Okay, so again the analysis will run, so the check will run, so under reiteration, and in this way the design will be completed. So it will again take, so it will choose another time, it will choose the next bigger section for columns and beam. In this fashion it will run the design check. Okay, so right now the run analysis is on completion. It is taking some time as per my system. So the analysis is completed. Okay, the analysis of this structure is completed. Now I can do the design checks. This is concrete frame design, and I will just ensure that this is as per the code. Okay, now I will do the design check on it. Okay, so it will take some time, and it will tell us whether the structure is safe or not, and it will tell us if it is not, then it will tell us how many members are filled in this design check analysis, and it will again reiterate, that is, it will try to replace those filled members for filled section by taking section of larger cross section, and in this manner it will make the structure safer. So Again we will see whether it is asking for iteration or not. It will take some time to run the design check. And after that design check, we can obtain reports of the project report from here, and from project report we can deduce several details of related to this structure. So it says that 705 concrete frames differ in the analysis, so it will reiterate the analysis and design. So on clicking yes, the software will try to replace the 705 frame section by replacing it by some bigger section that I have had already defined in the auto select list. So in this fashion it will run the design check, and once there will be no notification after the design check, we can have a selection here that is of all verify all member passed. Once the all members are passed, the design is okay. So in this manner the design analysis for this tall building is completed, and I'm very thankful that to Skylab that I have been given this project, and this is very interactive and structured program which is designed to make us familiar with the modern days software and try to apply it in practical life. Thank you for that.